Welcome to News About Geology. Today, we are diving into an absolutely groundbreaking story from the U.S. West Coast. It's a tale of accidental discovery, the kind that completely rewrites our understanding of earthquake risk and connects two seismic giants in a way that, nobody saw coming. Okay, let that sink in for a second. That's a pretty chilling thought, right? For decades, the big one, that massive, inevitable earthquake from the Cascadia Fault, has been the ultimate nightmare for the Pacific Northwest. So if that's not the worst-case scenario, then what on earth is?
To get our heads around this new threat, we first have to meet the two main characters in our geological story. For the longest time, scientists saw them as two totally separate, independent dangers: the Cascadia Subduction Zone and the San Andreas Fault. And here they are, in all their glory. On your left, you've got Cascadia, this 800-mile behemoth lurking just offshore, all the way from Vancouver Island down to Northern California. And on the right, the infamous San Andreas, another 800-mile giant that slices right through the heart of California. We're talking about two absolutely colossal forces, each one capable of just immense destruction. Now, while both of these faults are absolute giants, they work in different ways. Cascadia is a megathrust fault. That's where one tectonic plate is literally diving underneath another, which gives it the terrifying potential for a magnitude 9.0 quake or even bigger. The San Andreas, on the other hand, is what we call a strike-slip fault, where the plates grind past each other. It still packs a punch, topping out around a magnitude 8.3, but for decades, the thinking was they were two very large but very separate problems. The whole story of how we learned they might not be so separate begins with, of all things, a simple mistake, a really fortunate error during a research cruise that was about to change everything. So picture this, it's 1999, late one night on a research ship. The whole point of the trip is to study Cascadia, but a graduate student accidentally types in the wrong latitude. By the time they wake up in the morning, they realize they're 90 kilometers. That's about 55 miles, south of where they were supposed to be, deep into San Andreas territory. Now, instead of just turning the ship around and losing all that time, the lead scientist, Chris Goldfinger, makes this crucial on-the-spot decision: let's just take a sediment core right here, right now. And that spontaneous choice in a deep-sea canyon called the M9.0 Canyon would turn out to be one of the most important decisions in modern seismology. No exaggeration. So what did they find down there? The answer was hidden away in layers of mud, an ancient story written on the deep ocean floor. This is where geology gets so cool. It's basically detective work, but your crime scene is thousands and thousands of years old. The key clue here is something called a turbidite. Just think of it like this. When a massive earthquake shakes the seafloor, it triggers these huge underwater landslides. All that mud and sand rushes down into the deep and settles on the ocean floor, leaving behind a very distinct layer. So here's the bottom line. Each one of those turbidite layers is a fossil record of an ancient earthquake. Okay, so normally a turbidite layer is pretty simple. The coarse, heavy stuff settles first at the bottom, and the fine, light stuff settles on top. But the core from M9.0 Canyon showed something bizarre. A paired layer, a doublet, that was completely upside down. It had a fine grain layer at the bottom with a coarse, sandy layer sitting on top of it. Geologically, that just shouldn't happen. It defied all the typical explanations. And this was the big aha moment. The team figured it out. That fine-grained layer on the bottom must have been the distant whisper from a massive Cascadia quake, way up north. Which means the coarse, sandy layer on top had to be from a second, much closer earthquake on the San Andreas Fault that happened right after. This upside-down doublet was the smoking gun. I mean, this is just a perfect example of how geological detective work can rewrite the history books. And hey, if you find this kind of science as fascinating as I do, you should definitely check out the YouTube channel of PGO Ricardo Valls. He has some absolutely amazing content that dives even deeper into these exact kinds of topics. So that one single core sample kicked off years of more analysis. After they dated more cores all up and down the coast, the researchers reached a truly stunning conclusion. One that creates a brand new and frankly terrifying seismic reality for the entire West Coast. What the data shows is that a massive Cascadia earthquake can actually trigger a rupture on the northern San Andreas Fault almost immediately after. We are talking minutes or hours apart. This is a phenomenon called seismic synchronization. The two titans aren't separate threats at all, they're linked. One can literally set off the other.
So, what does this actually mean in human terms? I mean, to really grasp the scale of a twin rupture, let's first just look at an official study called the shakeout scenario. Now, this study actually models a big 7.8 quake on the southern San Andreas, not the northern part linked to Cascadia. But it gives us a powerful and honestly a terrifying idea of the kind of devastation just a single one of these big events can cause.
The human cost is just devastating. The scenario projects 1,800 deaths, and that's mostly from the collapse of older, more vulnerable buildings.
And beyond that, you're looking at an additional 53,000 injuries. That's enough to completely overwhelm emergency services. And the economic hit? A staggering $191 billion in losses from damage and business interruption. Now, you have to remember, this is the projected outcome from just one of these faults rupturing all by itself. And this right here is the key takeaway. As Dr. Goldfinger points out, a major quake on either fault alone would tax the resources of the entire country. But if they go off together, now you're talking about every major city from San Francisco to Vancouver, Canada, being in a state of emergency all at the same time. The scale it's almost unimaginable. Okay, so that is a truly terrifying thought. But here's the positive spin, and it's a really important one. This discovery, as scary as it is ultimately a gift, because knowing the true nature of the threat is the first and most critical step toward actually preparing for it. And look, this isn't just some theory sitting in a scientific paper. Authorities are actively acting on this science. What you're looking at here is the official response plan from the state of California for a Cascadia earthquake and tsunami. It's a hugely detailed document that outlines how different agencies will work together to save lives, using the best science we have to plan for the worst. So, how exactly does this knowledge help us? Well, first, it helps us write stronger, smarter building codes to make our cities more resilient. Second, it guides emergency response, making sure we can get resources ready for a multi-city catastrophe. Third, it empowers all of us, the public, to get prepared. And finally, it drives even more research to get an even clearer picture. This is science in action, and it's making us safer. You know, for thousands and thousands of years, the Earth has been writing this story of linked catastrophes in the mud of the ocean floor. We are the very first generation to have the tools to actually read it and understand the warning. So the crucial question isn't what the threat is anymore, it's what are we going to do about it? This whole story is just such a powerful reminder of how dynamic and interconnected our planet really is. To keep exploring these incredible geological processes, make sure you go visit the YouTube channel of PGO Ricardo Valls. Thanks for watching News About Geology.
Welcome to my channel, where you'll find over 2,000 videos on geology, geochemistry, AI, and many other subjects. If you like what you see, help us grow by subscribing, liking, and sharing this channel.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.